So in this lesson we are going to learn about combinations here, and hopefully by the end of this lesson you'll know what combinations are, how to calculate them, what they mean, and how to apply them to solve problems. So in making combinations, what we are doing is we are taking a specific number of elements from a set and we are making subsets. We are interested in the number of different possible subsets we can make where the order of the elements in the subset does not matter. Okay? And this is one of the big differences between combinations and permutations. In permutations, I'm just going to add this in here, permutations, we were all about taking the elements and arranging them. Okay? So if we're arranging things, the order that we put these things in is the only thing that matters. Okay? But in combinations, we don't care what the order of the things are that are in the set. We only care about what things end up in this smaller set. So an example of how a combination works is, let's say we've got a really simple set here, A, with just 3 elements, 1, 2, and 3. A question might be, how many 2-element subsets can we make, or how many ways can we choose 2 of the elements out of A and make a new set? Well, if we only have 2 things in the sets that we're going to make, we can, and there's only 3 things in A, this is the kind of question where we can list out all of the possibilities here. So we could pick the 1 and the 2, and that could be our new set. We could pick the 2 and the 3 to make our new set. We could pick the 1 and the 3. Okay, and those are all the possibilities. So how many 2-element subsets can we make? We can make 3 2-element subsets. Now, when we could take this set here, 1, 2, and we could reorder the elements 2, 1. Okay? That's what we were doing when we were doing permutations. Okay? So I've added this comment down here at the bottom. We can permute the subsets. But this set 1, 2 and this set 2, 1, they're the same subset. They have the same elements in them. So we don't consider these different subsets. So that's what I'm talking about. Order doesn't matter. We just care what things get pulled out of that set and put into that new set. Okay? So just to continue on with this question, what if instead of making a 2-element subset, we wanted to make a 1-element subset? How many different ways could we do that? Well, let's see. We've got, we could pull the 1 out, and that could be our set. We could pull just the 2 out, and that could be our set. We could pull just the 3 out, and that could be our set. So there are also 3 ways of getting a 1-element subset. What if instead we wanted a subset that had no elements in it? Oh, there's only one possibility. There's only one subset that has nothing in it, so that's only one possibility. And the only other size subset we can make from set A here would be a 3-element subset, where we take the 1, the 2, and the 3, because those are the only possible ways we can get 3 elements. So in this case, our subset is the same as our original set. That's okay. So there's only one way of doing that. So that's what a combination is. Okay? You are choosing elements from the set to make a new set. Okay? Now there is, like permutations, there's a factorial notation that makes the calculating of these things a little bit easier. Okay? So the number of combinations of and they're using these letters n and r again. So if we're taking r things from a set of n things, so we have n things in our original set, we're taking r of them out, or we're choosing r things out, is given by, there are several different notations. There's c, then in brackets n comma r, there's n, c, and then r. The one that we use a lot is nr, with these big brackets like this. The factorial formula is the same for all of them. N factorial divided by n minus r factorial times r factorial, down on the bottom. Okay. And however way this is written, we read this as n choose r. So again, n is the number of things in our original set. R is the number of things in the subsets that we are making. And the only restriction on n and r here is that obviously n and r are still going to be positive numbers, just like they were with permutations, and n always has to be greater than or equal to r, okay? Just like in the example that we did there. So let's just do a couple examples here of how you would calculate this using this formula. So the first one we have here is 9 choose 7. Okay? Just putting this into our formula, we are going to have 9 factorial on top, the first number. And then on the bottom, we are going to have the 9 minus 7, so 2 factorial. And then this is going to be divided by, also divided by, 7 factorial. That's our value for r. And then we can punch this into our calculator or work this out, and we end up with 36 here. Okay. You might also see this notation here, 6c4. Okay. Slide this over a bit. Again, what is this going to be? Our first number is 6, so we're going to have 6 factorial divided by, on the bottom, it's going to be 6 minus 4 factorial, so that's 2 factorial, and also divided by that 4 factorial right there. Now, some of these you can evaluate without using a calculator, using those factorial skills that we developed back in Unit 1. We could think of, 6 factorial as 6 times 5 times 4 times 3 times 2 times 1, which is just 4 factorial, divided by 2 factorial, 4 factorial, and then cancel out the 4 factorials, and this thing would be just 15. So either on your calculator, or sometimes you can use this factorial canceling that we've practiced. One thing to notice is that you can have different combinations which actually end up with the same value here. So if we're evaluating 3 choose 0, 3 factorial divided by 3 minus 0 factorial, or 3 factorial, 0 factorial, what is this going to work out to be? Well, 3 factorial over 3 factorial is just going to be 1. 0 factorial is just 1. So we get 1. If we come down to the bottom of this list here, and we're doing 3 choose 3, that's going to be 3 factorial divided by 3 minus 3, or 0 factorial, and then also divided by 3 factorial. So the expressions here are the same. We've got a 3 factorial on the top, a 3 and a 0 factorial on the bottom, and then a 0 and a 3 factorial. Because this is all multiplication and division, this is all just going to be the same thing. Similarly, here in the middle, I'll have 3 factorial divided by, let's see, 3 minus 1 is 2 factorial, and then 1 factorial. I should do the 1 before I do the factorial here, which is going to give me, let's see, 3 factorial divided by 2 factorial is just going to be 3. And if I'm doing 3 choose 2, 3 factorial divided by, well, 3 minus 2 factorial, 1 factorial, and 2 factorial, which is again just going to be 3. So in general, from this first one here, anytime you're doing a combination and you have n things and you're choosing none of them, there's only one way that you can choose 0 things. Okay? That's the null set. If you have n things in your set and you want to choose all of them, again, there's only one way you can pick all of them. So that's also 1. And then anytime, the other relationship is, if you've got n things in your set and you want to pick one of them, the answer is always just going to be n. Okay? So these are ones that you'll kind of come across a lot while you're evaluating these combinations. So it's not like you have to memorize them, but you will get to know them after you've done a few problems here. Speaking of problems, let's try a typical combination problem here. How many committees of 3 people can be chosen from 3 men and 4 women if, well, first one here, there are no restrictions. So we want to make a committee consisting of 3 people. We've got, how many total people do we have to choose from? Well, we have, in this first question, 7 people to choose from. How many of them do we want to choose? We just need to choose 3 of them to be on our committee. So the answer is going to be 7, choose 3. And we can work out what this is. 7 factorial divided by 4 factorial divided by 3 factorial. Punch it into our calculator. We get 35. Now the question becomes a bit trickier when we put restrictions on how we want to select our individuals or how we want to choose them. So if we want the committee to have no men on it, we only want to choose women. So now we really only have 4 people that we can choose from because we only have 4 women in our pool. So we can say there are 4 women. Okay. How many of them do we want to choose? Again, we want to choose 3 of them. So we want to have 4 choose 3, or 4 factorial divided by 1 factorial divided by 3 factorial, and this is just going to be 4. Now, what if we want to have exactly 2 men? Okay? In other words, what we want is 2 men and 1 woman on our committee. In this case, we can take the choosing in 2 stages. We can look at how many ways can we choose the 2 men, how many ways can we choose the 1 woman, and then figure out the total number of possibilities here. So if we're just looking at the men, first, how many men do we have in total? Well, we have 3 men. We want to choose 2 of them. So we've got 3. We're going to choose 2. Okay. Our combination is going to be 3, choose 2. If we're looking at the women, how many total women do we have to choose from? Well, we've got 4. We want to choose 1 of them. So that combination is going to be 4, choose 1. Now, for the total number of possibilities, we multiply, okay? Fundamental counting principle from Unit 1. The number of ways we can get the first thing times the number of ways that we can get the second thing. So, give myself a bit more space here. And we can work out what this is. 3 choose 2 works out to be 3. 4 choose 1 is just going to be 4. So in total, there are 12 different ways we can choose this committee of 2 men and 1 woman. Now, the last question here is the trickiest one. How many ways can we choose this committee so that it has at least 1 man on it? Okay? And there are 2 different methods we can use here. If it has at least 1 man on it, how many men can there be, or what are the possible values for the number of men? So what are the actual numbers then? So we can have 1, 2, or 3 men on our committee. One method of doing this is the indirect method. And what we do here is we calculate the total number of possible combinations that we have. Okay? We subtract the number that have no men. So if we take the number of possible committees we can make, we subtract the number that have no men on them, what we're left with are the ones that have 1, 2, or 3 men on them, or at least 1 man. Number with at least 1 man. So what are the total number of committees we can have? Well, we did that up in Part A here. We found out that that was 35 from Part A. Okay. How many ways can we make a committee with no men on it? Well, we found that actually in Part B. Okay. That was 4. So that leaves us with 31 committees that have at least 1 man on it. Okay. Now that's the indirect way of doing this calculation. You can also do it, and I'm afraid you won't have enough room on your page there, but we can also do it using what's called the direct method. Okay? We could say that the number with at least 1 man is going to be the number of ways we can get a committee with 1 man plus the number of ways we can get a committee with 2 men plus the number of ways we can get a committee with 3 men. Okay. Now this involves a lot more calculation. Okay? Because each of these calculations here, 1, 2, and 3, is going to involve a calculation similar to this one up here that we did in Part C. Because we have to think about how we can choose the men and how we can choose the women. Okay? So the number of ways that we can choose a committee with 1 man is, well, let's think of the men first. We have 3 men, and we want to choose 1 of them. For the women, we have 4 women. We want to choose 2 of them. So I'll just label this. These are the men, and these are the women. Okay. So there are there's 3 choose 1 ways of getting our man. There are 4 choose 2 ways of getting are women, are 2 women. If we want to have 2 men on the committee, again, we have 3 men to choose from. We want to choose 2 of them. For the women, we have 4 to choose from, but we only want to choose 1 of them. And then if we want to figure out how to get 3 men on our committee, well, we've got 3 men. We want to choose all 3 of them. And we don't want to choose any of our women. And then we can go ahead and work out all of these combinations. What we get for the first set is we get 3 times 6. Over here we get 3 times 4. We've actually already done this calculation. And then here we get 1 times 1. So our total number is 18 plus 12 plus 1, which gets us 31, just like the other method. So usually the indirect method requires a little bit less calculation, but you can also do it using the direct method.